beyond unit tests. Let's start that everything that I have in that I'm gonna show you today is under this QR code on the GitHub repository. You can find example expense tracker app, and all of the tests that I'm gonna show you are there and a bit more. And you have a link back to the presentation if you need. So if you like something and you wanna kind of go back afterwards, feel free to do so. We're probably gonna post it somewhere on a Slack group or on a meetup.com. Cool. What are we gonna talk about today? So first of all, when to use something other than unit tests. It's great to have more tools at our disposal, but first of all, you have to know when to use them, right? Like more hammers, if you don't know when to use them, don't really help. I'm gonna show you a few of the patterns that I use a lot for working with database. That's probably the most used integration test that we have, and I assume a lot of you have as well. Testing APIs, so when you have an application that serves API, maybe it's just a service that serves only API, how to test those. And last one, testing entire app, so more of an end-to-end test. If you have something like a service that you kind of want to spin up and test that it works from the very beginning to very end, it builds a Docker image for you and tests that, so we can test what you're gonna be running on production, not only what you have on your local machine. And we're gonna focus a lot on how to make those tests easy to read, and I won't say pleasant to write, because there's always some caveats, but it's not gonna be dreadful to write. It's gonna be something that you're not gonna dread when you like get the ticket of like, okay, let's finish our feature with integration and unit and end-to-end tests. So going back to the title, when unit tests are not enough, when we have to go beyond them. I wouldn't say, for myself at least, any tests came natural to write in the beginning. When I saw the concept of tests, I was like, why would you test the code you wrote? I know it works. Some wise people along the way told me, well, some other developers are gonna come after you and they're gonna be like, what the fuck is this? Like, how do I run it? How do I make sure that doesn't break? And I guess with experience, I learned that what they meant is like, me in the future is gonna come back to the code I wrote, and I'm gonna be like, what the fuck, does it even work? So yeah, while no test came easy to write, at least for me in the beginning, I would say integration tests felt the most natural. So it's kind of what I, and probably many of you do, you write some piece of code, you open your app and you click through it to kind of see, okay, does it work or does it not work? And some of the first tests were, you didn't mock anything, you just kind of spin up, you write your code and it connects to database and it tests if something works. And along the way, you learn unit tests, and you're like, okay, I have to mock everything, I have to test, have a very good test coverage. You go into this direction, but at some point you realize that it doesn't really cover everything. I mean, unit tests are great, don't get me wrong, you should have a lot of them. But if you use a lot of other stuff like database, you're not gonna be able to test everything. I've seen people who write unit tests in which they catch that the SQL they execute is the same as they expect it to, but it's not something I would recommend. It's better to connect to the database and actually check, okay, does it return me what I need? We're not gonna go too deep into that, but oh, I think I forgot a few of the points. So yeah, one of the points of integration and end-to-end test is testing the different components interacting with each other. Second one would be to test that the setup is actually working. I have an incident where the code was good and unit tests were good, but someone forgot to add a logger in a setup that go, and it somehow got to the production. And as you can imagine, the panic came quite soon. I really love using end-to-end tests, especially for testing crucial parts of whatever I have in my whatever I deem or my business deems crucial for the business. So if you have an application that's about sending documents, you would want to know that, have those smoke tests that whatever you did, customers still can open the app, go to whatever page they have to, click send documents, and those documents get sent somewhere, hopefully where we expect them to be sent. Yeah. Some people say that this is kind of where the industry is going, meaning that you used to have a pyramid with the unit test being at the bottom, the biggest. It's kind of still the biggest here, but as time went on, integration tests became more and more important because we have more and more tools that we integrate with. It's not only database nowadays. You probably use something like Redis for caching or for some quick gathering of data, and maybe you have Kafka or Google pops up where you have to send an event and receive it at the other end. So it grows more and more, and you would like to know that those components interact with each other the way you would want. Let's go to database. So database is probably one of the most used additional component in most of the applications. I wouldn't say that integration tests for like the simple CRUD operations where you have to just add something that's simple, update a field, update a title of article. That's probably, you can write those, but this is not where the integrations, in my opinion, shine. It's when you have a bit more complex queries. So, for example, if you have periods in your database, and you have a constraints that make it so that the periods can't overlap, that's becoming a bit more complex, and you would want to know that the constraint is there and it works as you would expect it to. Same with if you do some more complex views, some complex groupings, summing up, stuff like that. It kind of gets, you can do it in code as well, and then you need to test that, but at some point of scale, it's gonna be a lot slower than just using database. Yeah. So I have prepared a little diagram to kind of help show what we're gonna be doing today. So we're gonna be using test containers. In the past, I think this is one of the issues for me with testing database or any integration tests, where you would have to spin it up. Maybe you had Vagrant or something like that. Then you would kind of hope that every test is executed one by one. It would usually be very slow. You couldn't do those in parallel. And you were hoping that whatever the developer has, it works in your database, has the same configuration. It was not a nice experience, at least for me. And then came test containers. And the way they work, so you have your host machine. This is where your Go code is. Your IDE, for example, you click run test there, right? And to conceptualize what's going to happen is at the beginning of your test, doesn't matter where, you can kind of set it up however you want. It spin ups, in this case, Docker Compose. You can use build single Docker images, so you don't have to use Docker Compose, but I'm gonna be using Docker Compose for all of the examples here. And then you run tests, and each test connects to this database. And this happens usually for every package you have. You can pick granularity, but usually, because Go tests run in parallel, if you have multiple packages, all of them are gonna be executed depending on how many CPUs you have. So if you had only one database, you would get race conditions, and like repeating tests could fail. One test adds something to database, the second one removes it. Not nice. And you have to take care of centralized seeding, make sure that nothing ever overlaps. With this, you can make sure that your test has its own database to which it sends, on which it executes tests. We're gonna go through some code. Don't worry about the details. I just wanted to show you Docker Compose that's actually used. It's not that important to understand it fully. I'm gonna show you the parts that matter the most. So, like you saw on the first diagram, we have DB at the very top at the line 3, and we have migrate that just kind of waits for our database to be up, runs migrations, and exits. And then we have a port, because we have to connect with the database from our host. And important note, it hurt my company a lot, so I would like you to not repeat the same mistake. Use random ports. This means that this port is gonna be open on the container. So whatever you have on container on that port is gonna be opened on a random port on the host machine. So that's very helpful, because otherwise you're gonna execute your tests, and some of them is gonna fail because they're gonna use the same port, and you can't have the two applications running on the same port. It's very, very helpful on CI as well. You never know what's happening on CI. It's better to have a Docker figure out which port we're gonna be using. And this is our Go code. I simplified it a bit. We're gonna go line by line, so we're somewhat on the same page. First, we kind of start the Docker Compose. We specify the name of it. Then we tell our test containers, hey, like if you start, wait until our migrate exits. You can use the few wait strategies. You can wait for logs. You can wait for health check. In this case, migration runs in separate container. It runs migrations. It exits, and then I know that my database is ready. So that's what we did here. We have to get that port because it's random, so we don't know what it is. We have to ask Docker, hey, where did you put my stuff? How can I connect to it? Then we're gonna open a connection to that database, so it's just a bit easier to use it. And we called it startDB. It's gonna come later. It's a helper that we're gonna use quite a lot. And now to the code itself. It's only one test, but I want to kind of mention, because that's gonna be a recurring theme. This is really how a lot of tests in my company look like. They are very simple, at least from the view of it, because it's very important for me that if you look at the test, you don't have to go through 80% of boilerplate. You can focus, okay, what are we testing? So first, we start database, and we initialize our repository with the connection we just made to that database, right? So it's in the beginning of a test. And then we have our test. So we want to test if we can add an expense to our expense tracker app. You have initialization of the request we're gonna do. It's simple HTTP in this case, a REST HTTP. Then Then we have expense repo, which is added, right? I kind of like to follow prepare, act, assert pattern. So we first prepare what we're gonna be doing, then we have what we are actually executing, and then the third step is testing if what we did actually succeeded. So here I make sure that there was no error. I don't expect here any errors. I want to make sure that the expense I added is there. So I found it and that it looks like I expect it to look. So in this very simple case, it should look the same as my request. Take a look at this line. We're not gonna spend too much time on it, but at least the way I see it, your helpers should not be too complex, because then you're gonna be starting to test your helpers. Like if your helper is getting too big, how do you know that it's working? Like you start doubting yourself. So what I usually have is set helpers that will just truncate entire table and put whatever I had in my object, and then I have get all that tests that everything in the table looks like I expect it to. Of course, it depends, and sometimes you're gonna have like helpers like find by ID. This is actually something a unit test in this example. So you're gonna have your expenses object on which you can have like find by ID that looks within itself, and you can unit test that, so you know that find by ID works. And then when you have your helper for integration tests, you have very simple code. If you go into the get all expenses, it's like 8 lines of code where you kind of initialize whatever ORM you use, or maybe you don't use ORM. You get everything and you just set it. Like very simple. So we know that our helpers don't need testing. And let's go with testing APIs. So similar, but a bit different. So on our host machine, we spin up database, same code as before, but then we have to test HTTP server. This is something we can use from Go. It has already all of the code to HTTP test your stuff, and we can initialize it with a connection to the database. So whenever you do any calls to it, it actually uses database. And similar as before, you run all of the tests. I'm using HTTP here. Sorry, more of a REST-ish API. We use this pattern for gRPC and GraphQL as well, so you can use it with anything you have in your company. And yeah, we're gonna go through it. So don't worry, it's gonna go line by line. First, we start a server. We're gonna get to that. The first test is summarizing expenses. So we have some SQL that takes care of grouping, summing by, and we want to make sure that it works. So if I call my slash expenses summarize, I want to get the response that I know that I know. Then I want to make sure that the status code is okay. Quite important. Nice. If that doesn't work, then probably testing the rest of the app doesn't make sense. And I want to make sure that the response I get is what I expect it to. We're gonna get to the helpers in a few minutes. For now, I just wanted to show you how the tests look with this. And a slight hint. So in this case, I'm accepting IDs from the client. So I'm using EU IDs. And I decided it's fine to accept them from the client as is, but you might be using you might need your API to assign IDs. So maybe you have auto increment ID, so Postgres takes care of that, or maybe you just wanna, for security reasons or other reasons, use generate ID on the server side. You can use a JSON assert library. It allows you to mock out some of the parts within, sorry, not mock out, not care about some of the parts, in this example in JSON, because, for example, you might be returning updated at, and you don't really care what's behind it, and you can't know what's behind it. So you're just like, I just care that it is there. I don't care what it is, and that's where JSON assert comes in. And we're gonna go to another test. So adding expense fails. Similar to what we had before, we call we call our API. Here is a nice helper we're gonna get into in a minute. So we use that so we don't have to prepare anything in advance. Then we're making sure that we get the status we needed and the response we wanted, similar as before. I personally like to test as well that it actually did what I wanted it to do in database. Controversial for some people. You don't have to, up to you. And now we're getting back to the start server that I was talking about. So it uses the same start database as we talked about before. Then it sets that DSN that we have there in environmental variable, so that when we set it up, it actually knows which database to connect to. And then we just start a new server with HTTP test. It's built into Go. If you haven't used, I really recommend that. Very helpful for testing all of the HTTP stuff. And yeah. I hinted at the helpers. This is all of the helpers we're gonna be talking about. And this is what changed how much I like integration tests quite a lot. And it's not only about helpers, but how can you use Go to have simple declarations like this. And there are a few Go goodies that allow us to do it. One of them is t.name. So t, you have t in every of your tests. Yeah, I'm not gonna reach there, but at the very first line, this is testing.t that you're gonna have in every of your tests that you're gonna write and that Go is gonna execute. So this t has a lot of nice helpers. One of them being t.name. So in the beginning, you could have something like request path in that get request helper, so it knows what to use because you want to give your request.json there. But if you use t.name, it uses test names, sanitizes them, and then you can use that to have a nice folder structure, and you can make sure that your tests, whenever you rename your test, you have rename folders as well, so that they stay in sync. You probably had that pleasure of someone changes the name of a test, then forgets to update the name of the file they're using, and then you look for the file and like, where is it? And then you realize, oh, someone forgot to rename it, and now it's like a totally different name that you would expect it to. It's up to you how you're gonna use it. I like to use test data at the front and then have request and response JSON. Another benefit of that is that you get your highlighting, so you can go into request and see it as you'd, in pretty colors and whatever IDE allows you. You can also use the same requests to use in Postman. So if you like to not do test first and maybe you want to spin up your app, do some Postman request to see if your app works, then you can use that JSON or GraphQL or whatever you have there and just put into your tests. Yeah, and it simplifies our GET request by one parameter to the function. The other one is fail now. I'm using require.noerror. It's from Testify. Doesn't really matter. I just like it more, but you can use, if you don't want to use that, you can use if error is different than nil, then tfail now with some logs. And it's another helper that allows us to not care about the error. You don't want to have like if error, then on a test level. You don't want to have too many if this then that, because it doesn't seem like a lot, but if every helper does that, then you start having problems with like boilerplate that you don't care about. You want to do requests, you want to see the response, you want to make sure that they're equal, and maybe you want to check if it's in database. You want it to be easy to read. Cleanup. Very, very helpful as well. If you're using test containers for integration tests, after you want to kill those Docker containers at the end of your test, because otherwise you're going to have a lot of containers on your app, on your system. So you want to make sure that they are cleaned up. And if you start a server, HTTP1 here, then you also should be closing it. And you can return a function that's going to be closing it. That's fine, but once again, we are simplifying. And another one, t.failed. It's very helpful with test containers once again, because when it's more about end-to-end tests. But when they fail, you kind of don't know why, because you start a container, it runs something, then it gets killed, and you have like, oh, like this request did not work, and you're like, why? So with this, you can, at the cleanup level, you can check, okay, like if it failed, give me all of the logs and print them out. So you can actually understand what has happened. Helpful on continuous integration as well. And for me, this is very important, that instead of having a bunch of if statements, passing some arguments, you keep it clean, you keep it easy to read, and we actually reuse helpers a lot, so you don't even have to write them. You wrote them once, and you just pass them to any new test you're gonna write. It makes it a lot less dreadful to write again. Yeah, and this is my favorite. It's more about end-to-end tests. You have a service, you want to spin it up, and you want to see if it works. I'm gonna start with like why you might want to do it. So in my company, we didn't use too much end-to-end tests, or if we did, we used Cypress. So it spin everything up. You'd have Cypress that kind of goes through the entire app. But I also like end-to-end tests for naming. Might be controversial because some people are like, where do end-to-end tests start? When do end-to-end tests end? But I believe that if you have your service that does one thing, in this case it's sending a document, I want to be able to test that it does its job, and I want to build an entire image as I would do it for production. I want to spin it up and I want to see if it works. And we came up to this because testing it manually was a pain. You would have before you could get to this simple flow of, you have some event, then you pick up the pipeline based on this event, then you send a document somewhere, and you want to make sure that this document was uploaded, and you want to make sure that some another event was sent on another end. We had I don't know, 5 to 10 minutes of setup in real application, because you would have to go through a lot of steps to make sure that something is like spin up correctly, that you have connected to external service that's gonna receive those documents. You wanted to set up an entire app in the correct way. And whenever the developer got a functional review of that, they were like, yeah, I don't know, it looks like it's gonna work. You change on that one line, shouldn't affect too much, right? And I have to spend 10 minutes testing that, and then and you're gonna spend 10 minutes testing that, and then maybe 20 minutes browsing Reddit or something, and then you're gonna come back to the next task. So this is where the idea came from. We wanted for this to be a lot simpler, and maybe we don't want to run do functional testing manually every time there is a small change. They're like, problem shouldn't break anything. We're gonna simplify it a little bit for this presentation. We're gonna use our expense tracker app, and when there is HTTP request, we're gonna get transactions from external service, and we're gonna add those transactions that are unique to our database. This is how it's gonna be working, and this is how it's gonna be looking on conceptually. So we start a mock bank service. Another one that's maybe controversial, but I don't like my tests depending on another stuff. The only test that they like to depend on other stuff outside of my control are the tests called contract testing. We're not gonna get into those, but they make sure that whatever you connect to did not change APIs that you care about. But for testing the service, I kind of don't want to be dependent on my bank. Well, in that case, bank maybe would work, but a lot of other services don't really have 100% of being up, and they also have rate limits and such. And I don't want my test to fail randomly because third-party app did not work, and it happens more often than you imagine. Then we're gonna spin entire app like we would do for production. Well, maybe not entirely like we do for production, because we're not gonna be connecting to Kubernetes, but we're gonna use exactly the same build for Docker image that you would use for production. And then we're gonna run, in this case, one test that's gonna request sync, and it's gonna make sure that things have synced. Yeah. Oh, and this one is a bit interesting, because in all of the previous ones, you had a host that was connecting to Docker. You could spin up mock bank API as another service that you connect to, right? That would work as well. We played around with it. But Go has such an awesome tools with for HTTP testing. So why not use those? It's much quicker. It's easier to read. You have it under your fingertips when you test, when you run tests, when you are testing, when you're looking for something, when it doesn't work, when you want to update something. So why not use those? So we can actually connect from the Docker to the host. Once again, Docker Compose we're gonna be using, but the details, like the same database and migrations, but we don't care that much about this. 3 services, so server, database, and migrations, like you've seen on the diagram. And this is a spicy sauce here that allows us to call host Docker internal, meaning if application from within a Docker calls host.docker.internal, it's gonna be connected with your host machine. On some systems, it will work without it. I think for Windows, it works out of the box, but on Linux, it doesn't. There are some caveats with macOS, but if you add this line to your service, it's gonna work. I tested it on every system, and that's what we use on GitHub continuous integration, which uses Ubuntu. It also works there, so you can run your end-to-end tests there. And once again, random ports. And yeah, let's take a look at how our test can look like. So we first start our mock bank API. We're gonna get to that a bit later. Then we start our application. We're not gonna get too much into that. It's similar to starting a service, except you just have your Docker Compose file with your Docker build, everything like you would have for your local machine. And you just kind of select that and you say, please spin it up. And then you probably want to wait for some kind of a log, or maybe you want to wait for health check, whatever you have set up there, to make sure that your API is ready to take requests. Usually the first test I like to run is make sure that it started, because all other tests don't really make sense if it did not start, meaning start successfully. So I do some random requests to get a lot of expenses, and I want to make sure that I just get no error, status code, okay. And then we can go to the real test that we actually want to check. So we got our address, didn't highlight it. We get our address, because remember again, we have our address is at random port. So we have to get address from our startup. So we call the address with, hey, please sync transactions. We check if it was okay, no error. And then we call expenses all in this case, and want to make sure that the new expense that we created is there. I guess I did not highlight. We have expense to sync. It's kind of yeah, doesn't matter. Expense to sync would be in a request in our mock, and now we can kind of check, okay, like it was not there before, now I'm expecting it to be there. Yeah. And then mock bank API. We're not gonna go through all of it. First part is easy. We just say, hey, like when someone calls get transactions, that's what we wanna give to them. And then we wanna start unstarted server. That's important because we wanna do some listener magic there. So Docker has IPv6 in experimental state, so you have to use TCP4, otherwise you're gonna have some problems. I think on Windows, I know on Windows it's gonna register under IPv6, and it's not gonna work because Docker doesn't have access to that. currently we would have to enable some experimental features. And then we listen on everywhere and on random port. If you use 0 as a port, it means that it's gonna contact it runs on a host machine. So it's gonna contact your host machine and ask like, what is available port for me? And it's gonna get one, again, random ports. And then that random port is gonna be used as a listener on the server. So when you start the server, we're using that random port to get data, to get requests, sorry. Once again, we want cleanup. Oh, and I did not highlight it, but like, this is what we wanna give to the server the app we're gonna be spinning up. So host.docker.internal and that random port we just got, because like we used at extra host, that address is gonna contact to the host, and that port is what we spin up our mock. And thanks to that, we can let know our test, like our container, where to ask when they have to get transactions to sync from our bank. We're not gonna go through all of it again because some of it is repeating, but now we're starting our entire app. We're passing our mock API as environmental variable because we're spinning up entire image. We can't just start something with the function. We have to spin entire image like we would do on production. So you have to pass everything through environmental variables. And in this case, we were waiting for the container to print a log running. There are other strategies, we talked about it. And then we started. And yeah, here is the part where you really want logs, because otherwise, if it fails, it's gonna be very hard to understand what has actually happened. And that's it. Before I take questions, I have one question for you. Don't answer to me. It's something to take home, think about, or talk after the production. How and when does it make sense to use a test main? If you don't know what test main is, maybe you can look it up. How does it? Where does it come with integration tests? Where does it come up with end-to-end tests? It's quite a helpful thing, but I'm gonna leave it for you to figure out on your own time. And yeah, any questions for me?
Are you starting this container?
Sorry?
Are you starting in test main?
Some of them. Some of them, yes.
About different services and just simply guys, for example, like SQS or something. So you would create lots of parallel.
Yes. Możemy przejść na polski. Bardziej mi chodziło o prezentację. Tak więc.
Bo jak tam była baza danych, to możemy się baz danych, aby różne porty, to rozumiem. API-em, no to jeszcze można użyć tego samego, ale na przykład jak masz kolejkę.
Tak. Nie wiem, jak to wygląda w przypadku AWS-a, ale na Google dostajesz emulator kolejek, nie? Tak samo Kafkę możesz na przykład spinować w kontenerach, więc żeby pokazać to na przykładzie, to tak samo jak właśnie bazę danych, czyli będzie tutaj łatwiej? Chyba tu będzie łatwiej. I my właśnie używamy używamy właśnie w jednym z wszystko bardziej skomplikowane. Właśnie mamy serwer, mamy bazy danych, mamy migrację, mamy Redisa, coś tam do autoryzacji i mamy właśnie Kafkę. To wszystko idzie w jeden kontener i startujesz cały kontener, czyli masz swój Docker Compose. On będzie wyglądał prawdopodobnie bardzo podobnie do tego, co już używasz, żeby testować rzeczy lokalnie. Tylko tutaj właśnie pytanie, czy AWS ma swoje emulatory do Dockera?
Ale to teraz mi chodziło o to, że entry pointem jest kolejka, nie?
Mhm. I
Aplikacja nasłuchuje, a ty musisz tam coś wysłać, aby
tak.
sobie przeszedł.
Mhm. To my robimy tak, że podobnie jak tutaj startujesz na przykład takiego mocka, właśnie ten pierwszy, no dobra, startujesz sobie tam mocka, cokolwiek potrzebujesz, może nie, potem startujesz cały kontener, tam się odpala cała kolejka i twoja aplikacja zaczyna nasłuchiwać na kolejkę. Potem w teście wysyłasz event do tego AWS-a, musisz sobie do tej kolejki, musisz sobie przy tym startupie zwrócić adres, gdzie możesz to wysłać. Wysyłasz tam event, na który chcesz, żeby to zareagowało i my używamy czegoś takiego, że czekamy do 10 sekund, na event, który ma wyjść z drugiej strony, albo nie wiem, coś tam ma się stać w bazie danych. Tam sobie czeka. Jeżeli po 10 sekundach nie dostało odpowiedzi, no to zakładamy, że test failował. To musicie sobie wyważyć w zależności od tego, jak szybko aplikacja działa, nie? Ale no my w przypadku kawki lokalnej to tam 10 sekund spokojnie. No on tam sobie, i jeżeli po drugiej stronie to też wysyła event i my po prostu czekamy na ten drugi event. Jak ten drugi event dostaniemy, to znaczy, że nasz flow przeszedł, potem można sprawdzić na przykład, czy nasz mock został skalowany, albo czy był kontakt do naszego mocka. I wtedy uznajemy, i czy ten kontakt wygląda tak, jak oczekiwaliśmy, w zależności co tam testujesz, no i albo sprawdzasz coś tam w bazie, nie wiem co tam robicie i w tym momencie uznajesz, że ten test przeszedł. I to jest właśnie rzecz, dla której chcieliśmy mieć te testy, bo właśnie rzucanie tych eventów manualnie do serwisu, potem patrzenie, czy to się tam mieli jeszcze i potem sprawdzanie w bazie danych, po prostu męczące było, nie? Więc po prostu opłacało się. Wiecie, ja też nie mówię, że to jest, że usiądziecie i tam w pół godziny będzie zrobione, to chwilę zajmuje, żeby to wszystko postawić, ale u nas naprawdę dużo czasu oszczędziło. I właśnie głównie z eventami najwięcej zabawy, bo masz serwis, który przyjmie jakieś eventy i potem wydaje jakieś eventy, no i weź to teraz testuj. Wytłumaczyłem w miarę? Mhm.
Jak traktujecie kwestię tego, że kiedy uruchamiacie sobie te testy na kontenerach, no bo to pewnie potrafi kosztować trochę czasu, zasobów i tak dalej, no jak pipeline taki odpalisz z powiedzmy nawet kilkunastoma takimi kontenerami otworzonymi dla jakichś konkretnych testów, to nie wiem, na każdy commit sobie to robicie, czy
Na każdy pull request.
na każdy pull request?
Tak. Test kontenery działają naprawdę szybko. Jeżeli używasz samej bazy danych, czyli o pierwszych dwóch, których mówiliśmy, te testy są naprawdę szybko. Nie mam cyfr, ale na każdy pull request to idzie i zawsze koniec końców czekamy, aż się nasz klient w JS-ie zbuduje. Testy są szybsze, wciąż integracyjne. Więc nigdy to nie jest slow point. Nie mówię też, że one tam się odpalają tak szybko jak unit testy, to wiadomo, ale takie zwykłe bazodanowe to naprawdę szybko leci. My mamy też co prawda dość taką potężną maszynę na CI, ale to też nie jest jakaś tam przesadnie, tam 16 GB RAM, chyba 8 procesorów, więc porządna, ale też bez przesady. I mamy pewnie już teraz setki tych testów i one tam integracyjne się w 3 minuty robią. To naprawdę fajnie działa. I właśnie to jest duży plus, że to jest wiele naraz się spinuje, nie? Bo Go sprawdza, ile masz procesorów, patrzy 10, dobra, no to będę 10 paczek naraz testował. I jak 10 naraz leci, wiadomo, to jest trochę resources intensive, ale jak masz porządną maszynę, no to naprawdę ładnie leci, nie? W porównaniu do czegoś takiego jak kiedyś, jak miałeś Vagranta, gdzie miałeś jedną bazę danych i musiałeś ją restartować po każdym teście, no to nieważne, ile tych procesorów miałeś, to po prostu nie działało szybciej, a tutaj naprawdę fajnie działa. Można też sobie te testy rozbić. My na przykład osobno uruchamiamy testy end-to-end i integracyjne w osobnych jobach w GitHubie. Chciałem dojść do CI tutaj też, ale widziałem, że tak czasowo nie do końca mi się spinam. I my używamy build tagów, żeby egzekutować tylko testy integracyjne i tylko testy end-to-end. Prawdopodobnie można użyć jeszcze więcej, jak tych testów jest naprawdę dużo. Ale my jeszcze nie doszliśmy do takiego momentu. Ok, nie widzę więcej pytań. Dziękuję bardzo za uwagę.